Good morning, everyone. Now, today we are going to do sum. This 7 raised to n minus 3 raised to n is divisible by 4. We take the statement is given statement, that means P of n for every natural number. First we prove this statement is true for n is equals to 1. For n is equals to 1. So we substitute n by 1. Here in statement we can write n is equals to 1. So 7 raised to n is 3 raised to n. That means 7 minus 3 is equals to 4. And we know that 4 is divisible by 4. Therefore, P1 is true. આપેલું સ્ટેટમેન્ટ 1 માટે ટ્રુ છે એમ ક્યારે કહી શકાય? અહીંયા જે કોઈ નંબર આવે એ 4 એ divisible હોવો જોઈએ. Here we have 4 and we can say that 4 is divisible by 4. If here 12, then we also say that 12 is also divisible by 4 and therefore P1 is true. If here 24, then we can also say that 24, that means given statement is true for n is equals to 1 because 24 is divisible by 4. Okay. If here 40, then also we can say statement is true for n is equals to 1. So we say that P of 1 is true. Now we assume that P of k is true. That means given statement is true for any natural number k, and therefore we can write exactly statement P of n, but we can write k when we say n. So 7 raised to k we assume that is we assume that this statement is true. Okay. 7 raised to k minus 3 raised to k is divisible by 4. Therefore we can write 7 raised to k is equals to 4 lambda, where lambda belongs to n. Lambda is any constant. You can also write 4d, 4x, 4y, any number. Okay. From this we can make 7 raised to k as subject. So value of 7 raised to k is 4 lambda plus 3k. Not necessary. From this you can also make subject 3 raised to k. So we have 7 raised to k minus 4 lambda. Okay. That means if here 2-3 steps you can make subject any term. Okay. If 7 raised to k is subject, then we have value 4 lambda plus 3k. And if we make 3 raised to k subject, then 3 raised to k is equals to 7 raised to k minus 4 lambda. You can take any one of these. No changes in answer. So number 1. Okay. Now we have to prove P of k plus 1 is true. We can write k plus 1 when we see n. So we can write 7 raised to k plus 1, 3 raised to k plus 1. Now we have to see 7 raised to k plus 1 minus 3 raised to k plus 1 is divisible by 4. That means this term has one factor as 4. Okay, you see that from 1 we have value of 7 raised to k. So first we split this term, so we can write like this: 7 raised to k into 7 raised to 1 minus 3 raised to k plus 1. Now from result 1 we replace value of 7 raised to k. So here I can write 4 lambda plus 3 raised to k into 7 raised to 1, that means 7, minus, I also split this term, so 3 raised to k to 3 raised to 1. Now we open the bracket, that means 7 4s are 28 lambda plus 3 raised to k into 7 minus 3 raised to k into 3. From these two terms we can take 3 raised to k common. So here 7 minus 3. So 28 lambda plus 4 into 3 raised to k. And now we can take common 4 from these two terms. So we can write 4 in the bracket 7 lambda plus 3 raised to k. Here we have 4 as one factor. 4 એક ફેક્ટર તરીકે આવી ગયો છે. બ્રેકેટમાં કોઈ પણ ટર્મ આવે, this term is divisible by 4 because આ જે ટર્મ છે એનો એક ફેક્ટર 4 છે. અહીંયા જે કોઈ ટર્મ્સ આવે એની સાથે કોઈ વાંધો નથી. Here 4, that means which is divisible by 4. અહીંયા એવો નંબર આવે કે જે 4 વડે ડિવિઝેબલ ના હોય તો પણ વાંધો નથી, બીકોઝ એક ફેક્ટર આનો એઝ અ 4 મળી ગયો છે. ધેરફોર p of k is true implies p of k plus 1 is true, and therefore by PMI given statement is true for every natural number. Okay, PMI, that means principle of mathematical induction. In short, multiple of 4 बतावવાનું હોય કે divisible by 4, simplify કરીને bracket ની બહાર જેના વડે divisible બતાવવાનું હોય તે ફેક્ટર આવવો જોઈએ. Okay, now next term. X raised to 2n minus y raised to 2n is divisible by x plus y. ઓકે, અત્યાર સુધી જે સમ જોયા તેમાં ડિવિઝેબલ બાય કોઈ ડિજિટ આવતા હતા, 11 8 27 4 એ રીતે. હવે આ જે સમ છે એમાં ડિવિઝેબલ બાય x પ્લસ y, ધેટ મીન્સ વેરિયેબલમાં બતાવવાનું છે. મેથડ એની એ જ રહેશે. ઓકે, ધેટ મીન્સ અહીંયા જે ટર્મ્સ આવશે એનો એક ફેક્ટર x પ્લસ y બતાવવાનો છે. ઓકે, ફોર ઓર ફર્સ્ટ વી પ્રૂવ p of 1 is true, that means for n is equals to 1. So here we can write 1 whenever we see n. So x raised to 2, so x square minus y square, and you know factor of x square minus y square is x minus y, a square minus b square, then a minus b, a plus b, and one factor is x plus y, so which is divisible by x plus y, and therefore we say that p of 1 is true. Okay, now we assume that p of k is true, that means statement is true for any natural number k. So we can write statement P of k. X raised to 2k. જ્યાં જ્યાં n દેખાય ત્યાં k લખવાનો. Minus y raised to 2k is for every natural number. And therefore rewrite x raised to 2k minus y raised to 2k is equals to x plus y into lambda, where lambda belongs to n. That means lambda is any natural number. ये શું આવે છે એ કાલે મેં તમને એના પર આ રીતે બતાવ્યું છે. 11 હોય તો 11 ones are 22 હોય તો આ બધી ટર્મ્સ every terms are divisible by 11, and for 11 lambda is 1, for 22 lambda is 2, for 33 lambda ની વેલ્યુ 3 અને 3, અને for 44 lambda is 4. ઓકે, આગળના લેક્ચરમાં પણ આના પર આપણે ડિસ્કસ કર્યું છે. Now we make subject x raised to 2k. So x plus y into lambda plus y raised to 2k. Number 1. Not necessary, you also make the subject term y raised to 2k. Then you have to write y raised to 2k is equals to x raised to 2k minus x plus y into lambda. Okay. To prove, now we have to prove P of k plus 1 is true. So we write k plus 1 in the given statement when we see n. So we can write x raised to 2 in the bracket k plus 1 minus y raised to 2 in the bracket k plus 1. And now we have to see that or prove that this term is divisible by x plus 1. That means by expanding of these two terms, we have one factor as x plus 1. Okay. So now I can write 2k plus 2 minus y raised to 2k plus 2. And as we see in result number 1, we have value of x raised to 2k. So I can split this term. You already learned chapter power and exponent. And now we can replace value of x raised to 2k from 1. So x plus y into lambda plus y raised to 2k. We replace value of x raised to 2k from result 1. Now this is the value of x raised to 2k. X square as it is minus y raised to 2k into y square. Now we open the bracket. That means these two terms are multiplied by x square. So here we have x plus y lambda into x square plus y raised to 2k into x square. This term is as it is. First term is as it is. Now from these two terms we can take y raised to 2k common. So here x square minus y square. Y raised to 2k is common. So x square minus y square. Now we factorize x square minus y square. The factor of x square minus y square is x plus y, x minus y. And you can see this. We can take x plus y common from these two terms. So here lambda x square plus y raised to 2k x minus y. When we take any term common, you have to underline this term. So you know very well which terms are in bracket. X plus y is common, so here only lambda x square. Here x plus y is common, so remaining term is y raised to 2k x minus y. And now we say that is divisible by x plus y, because by simplifying these terms we get x plus y as one factor, and therefore we can say P of k is true, implies P of k plus 1 is true, and therefore by PMI, that means principle of mathematical induction, statement Pn is true for every natural number. Okay. Now last sum of this chapter. We have to see by principle of mathematical induction, and n plus 1, n plus 5 is a multiple of 3. Multiple of 3, otherwise divisible by 3. Both things are same. Now first we prove statement is true for n is equals to 1. So for n is equals to 1, we take this term. So here 1, 1 plus 1, 1 plus 5. So 2 into 6. So we have 12, and 12 is multiple of 3, because we can write also this 3 into 4 is multiple of 3. Okay. So we say that therefore P of 1 is true. Okay. Now we assume that P of k is true. So statement P of k is, for P of k we can write exactly statement Pn, but when we see n is replaced by k. So here k plus 1, k plus 5 is multiple of 3, and therefore we can write therefore k plus 1, k plus 5 is equals to multiple of 3. So we can write 3 lambda, where lambda belongs to n. That means lambda is any natural number. Now here only we have one term, so we can expand k as it is. First we multiply these two terms, k plus 1 into k plus 5. So we have k square plus 6k plus 5. You all know, you all studied in standard 8 multiplication of these two brackets, k into k, k square plus 5k plus k plus 5 ones are 5. So k square plus 6k plus 5. જેને ડાયરેક્ટ નહીં ફાવે આ રીતે સાઈડ પર મલ્ટીપ્લિકેશન કરીને લખો. Okay, now k is multiplied by this bracket. So k cube plus 6k square plus 5k is equals to 3 lambda. Result number 1. Okay. To prove P of k plus 1 is true, we have to write k plus 1 when we see n in given statement. And in given statement we have n plus 1, n plus 5. So when we see n is replaced by k plus 1. So k plus 1, here n is replaced by k plus 1. So k plus 1 plus 1. And here k plus 1 plus 5. So we have here k plus 2 and here k plus 1 plus 1. So here k plus 6. Okay. Okay. So I can write again. So k plus 1 as it is. Here k square 6 plus 2 8k plus 6 2s are 12. Okay. So lakવામાં be careful. Now we multiplied this bracket. So a cube plus 8k square plus 12k plus k square plus 8k plus 12. આ રીતે કરો અને અહીંયા જો 10 આવ્યો તો મને ખ્યાલ આવ્યો 10 માંથી 3 કોમન નહીં નીકળે. સો આઈ નો સમથિંગ ઇઝ રોંગ, એટલે પાછું પહેલેથી જોઈ જવાનું. ઓકે. ના ઇન રિઝલ્ટ 1 we have value of k cube plus 6 square. So I can write. Question change nahi thavo જોઈએ. Here 8k square then here 6k square. So I can write. Okay, first we add k cube plus these three terms are like them. So 9k square, 12k plus 8k. So 20k plus 12. Now we adjust from result 1. So k cube plus 6k square plus 5k. Here 9k square and here 6k square. So I can write 3k square. Okay. Here 20k and here 5k. So I can write 15k and 12 is as it is. Okay. Term change नहीं रहेगी. आने expand करो आ term आ जैसे k cube 6k square plus 3k square. So 9k square. 5k plus 15k 20k and 12 as it is. Okay. અને સ્પ્લિટ કેમ કર્યું? રિઝલ્ટ 1 માં આપણી પાસે k ક્યુબ plus 6k square plus 5k ની વેલ્યુ છે માટે. Now from result 1 આ ત્રણ ટર્મની જગ્યાએ we can replace 3 lambda અને આ ટર્મ as it is. Plus 15k plus 12. And now you can see 3 is common from every term. So 3 is common. So in the bracket lambda plus k square plus 5k plus 4. So 3 is one factor of this term. So we can say is multiple of 3 and therefore Pk is true implies P of k plus 1 is true and therefore by PMI given statement is true for every natural number. Okay. ટેક્સ્ટ બુકનું એક એક્ઝામ્પલ છે. prove that AB whole raised to n is equals to A raised to n B raised to n. ટેક્સ્ટનું એક એક્ઝામ્પલ છે, ઇમ્પોર્ટન્ટ છે એટલા માટે કરી લઈએ. ઓકે, we have to prove this statement by principle of mathematical induction. Okay, so first for n is equals to 1, so we can take in this sum left hand side. So left hand side is AB raised to n, so we can replace n by 1, so AB raised to 1, so AB. In right hand side we can replace n by k, so A raised to 1, B raised to 1, so AB. So we can say LHS is equals to RHS. Therefore P of 1 is true. Okay, now we assume that this is given statement. So P of n for every natural number. Assume that P of k is true. So we can write that AB raised to k is equals to A raised to k into B raised to k. Okay. Now we have to prove P of k plus 1 is true. We take left side. So how we can write left side? In statement Pn, we can replace n by k plus 1. So left hand side is AB whole raised to k plus 1. Okay. Now expanding it, what we get? આને expand કરીને શું આન્સર આવે તો આપણે એમ લખી શકાય કે લેફ્ટ હેન્ડ સાઈડ ઇઝ ઇક્વલ્સ ટુ રાઈટ હેન્ડ સાઈડ. તો ફર્સ્ટ આપણે ડિસાઈડ કરી લેવાનું ને એ ડિસાઈડ કરવા માટે જે સ્ટેટમેન્ટ આપેલું હોય એની રાઈટ સાઈડમાં જ્યાં જ્યાં n દેખાય એની જગ્યાએ k plus 1 રિપ્લેસ કરવાનો. સો in short, આ ટર્મને સિમ્પ્લિફાઈ કરતા if we get A raised to k plus 1 into B raised to k plus 1, then we can say left hand side is equals to right hand side for P of k plus 1. Okay, now we can write like this by using rule of power and exponent. Base are same, the addition of power, so these two terms are same. Now we use the statement P of k, that means from 1 AB whole raised to k is equals to A raised to k into B raised to k. So we can replace value of AB raised to k. So A raised to k to B raised to k, A into B power. Okay, and from 1. Now base are same, so addition of power. Here also base are same, so and if we get A raised to k plus 1, A raised to k plus 1 into B raised to k plus 1, B raised to k plus 1, then we can write LHS is equals to RHS. Therefore P of k is true implies P of k plus 1 is true, and therefore by PNI given statement is true for every natural number. That means આ ટ્રુ છે એમ લઈ લીધું સ્ટેટમેન્ટ PK અને એનો યુઝ કરીને P of k plus 1 ટ્રુ છે એમ પ્રૂવ કર્યું by PMI, that means principle of mathematical induction. Okay, આ ચેપ્ટરમાં 3 સ્ટેપ. પહેલા p ઓફ 1 પ્રૂવ કરવાનું. ધેટ મીન્સ આપેલું સ્ટેટમેન્ટ n ઇઝ ઇક્વલ્સ ટુ 1 માટે ટ્રુ છે એમ પ્રૂવ કરવાનું. સેકન્ડ, p ઓફ k ઇઝ ટ્રુ. સ્ટેટમેન્ટ k ઇઝ ઇક્વલ્સ ટુ n ઇઝ ઇક્વલ્સ ટુ k માટે ટ્રુ છે એમ એઝ્યુમ કરી લેવાનું. ઓકે, એન્ડ ધેન p ઓફ k ટ્રુ છે એનો યુઝ કરીને p ઓફ k પ્લસ 1 ટ્રુ છે એમ પ્રૂવ કરવાનું છે. ઓકે, અને તેના માટે સ્ટેટમેન્ટની લેફ્ટ હેન્ડ સાઈડમાં n ની જગ્યાએ k પ્લસ 1 લખવાનું અને સોલ્વ કરવા માટે રાઈટ હેન્ડ સાઈડમાં n ની જગ્યાએ k પ્લસ 1 લખવાનું. આ લેફ્ટ સાઈડને સિમ્પ્લિફાઈ કરતા આ રાઈટ હેન્ડ સાઈડમાં n ની જગ્યાએ k પ્લસ 1 આવે. ધેન વી કેન સે લેફ્ટ હેન્ડ સાઈડ ઇઝ ઇક્વલ્સ ટુ રાઈટ હેન્ડ સાઈડ. ઓકે.